equations are lined up, but we don't have an x equals or y equals, and if we add down, we notice that the 1 and the 7 don't cancel, nor do the 3 and the 2. So what we do is we look at the least common multiple of the coefficients. 1 and 7 both go into 7, 3 and 2 both go into 6. Usually we choose the smaller of these numbers, which in this case is 6, and that's what I'm going to go with. I'm going to create 6 y's in each of those two equations. To turn this 3y into a 6y, I'm going to multiply that first equation through by 2. And the second equation, to turn the 2y into a 6y, I'm going to multiply that equation through by 3. I like to draw these arrows and right on top of the arrows what I'm multiplying through by. Multiplying that first equation through by 2, I now have 2x minus 6y equals 22. And the second equation, multiplying through by 3, we have 21x plus 6y is equal to 24. Now you were probably wondering why the hooey was he multiplying through by those numbers, but now you can see that these 6 y's are going to cancel each other out. And so adding down, we have 23x equals 46, and that 23 goes into 46 very nicely twice, so we're going to have x equals 2. Now we need to solve for y, and we can substitute it back into either of the original two equations. This second one has a 2y instead of a negative 3y. I'd like not to have that negative, and it's easiest to draw an arrow right back, whoopsie, to this equation. I want to substitute it in for x, not y. So I'm going to have 7 times that 2, which becomes 14, plus 2y equals 8. Subtracting the 14 on each side gives us 2y equals negative 6, and dividing each side by 2 gives us y equals negative 3. So the solution to this system is 2, negative 3. Very checkable. This next equation that we look at has c's and d's. It's a little strange dealing with c's and d's. We're used to dealing with x's and y's, but it's the same thing. We notice that the 6 and the 5 don't cancel, nor do the negative 2 and positive 3 in the next column. So again, we want to create this situation where we can eliminate a variable. 6 and 5 both go into 30. 2 and 3 both go into 6, and 6 is a much smaller number, so we're going to turn both of these d terms into 6's. To do so, that first equation is going to get multiplied through by 3, and the second equation is going to get multiplied through by 2. That'll create a negative 6 and a positive 6, which will cancel each other out. Multiplying that first equation through by 3 gives us 18c minus 6d equals negative 6. And multiplying that second equation through by 2 gives us 10c plus 6d equals 34. We designed it so that those 6d's would cancel each other out. So adding down, we have 28c is equal to 28, and dividing each side by 28, we can see that c is equal to 1. Now we need to find a missing value for d, and that's a nice, whoops, again I want to substitute in for c, not d. We're finding d. So we're going to have 5 times the 1 we substitute in. That becomes 5, plus 3d is 17. Subtract the 5 on each side to get 3d equals 12. Divide each side by 3 to get 4. So we have 1 and 4 as our answers, and when we are not dealing with x and y, but we have c and d, we write them in alphabetical order. So in this case, 1, 4 would be the solution to that system.